So descriptive statistics, as we just said, right? It is, it's a branch of statistical techniques that are used to describe patterns, describe features in more general terms of quantitative data, right? We said that surveys and experiments, they're quantitative methods, right? They gather numbers, they gather information that can be quantified in numbers. So, but when we gather a whole bunch of numbers, we try to see, first of all, whether there are certain features and patterns that we should pay attention to, and then we can go ahead to make guesses from those numbers about the things that we're interested in. Okay, so that's really, you know, descriptive statistics really is generally the first step in running all kinds of analyses. So there are many types of descriptive statistics, but we're going to focus on two, the most important two types of descriptive statistics, or the two, most important features about any data that statistics will be used to describe. That is the central tendency of data and the dispersion of data. Well, more precisely, central tendency and dispersion are features of the distribution of values. The question, of course, is then, what is the distribution, right? What does it mean when we say values have distributions? Okay, so let's sort of make sense of this question, or understand this concept distribution by looking at two examples. So example one is a very simple one. So how much do you like iPhone in general, right? This is like a very standard survey question that you will come across in daily life, right? So I provide a scale for you, and it's not at all ranging. It ranges from not at all to very much, right? From 1 to 7. So all you need to do is to circle a number, right? Okay, so of course we cannot do this, face to face. I do not know what numbers you choose, but let's imagine, right? Let's imagine that we're doing this face to face, and then we have 5 people in this class, including me, 6. Okay, so this 6 are, we can imagine as 6 respondents, right? Me including me and the 5 of you guys. Okay, and then a surveyor or researcher will repeat this question for each one of us. Okay, so let's say the first person, I don't know who, so I'll just say the first person um, is going to give a number 1. Okay, um, okay, so let's do it this way. Scratch that, but we can leave these numbers on. So instead of using 1, 2, 3, 4, 5, and 6 to represent the 6 of us, we can add a number 7 here to represent the 7 values. How about that? Because we do have seven possible values, right? And this is me. Okay, this is Andrew Jam. Okay. No, scratch that. I'm sorry. All right. So these, as I said, are 7 values, right? 1, 2, 3, 4, 5, 6, 7. Now, after you look at these questions, answer this question, I will ask you in turn, you know, does anybody choose a 1? Okay, imagine there's one of you, right? One of you chose 1. So I would say, aha, there's one person that chose 1. Okay? Then I'll ask the rest of you, well, does anybody choose 2? All right, so let's imagine that nobody chose 2. And then I'll repeat the question, did anybody choose 3? Okay, turns out there are 2 of you choosing 3. Okay? And then I proceed. Anyone chose 4, anyone chose 5. Turns out that there are 5 person. There are 2 people chose 5, and in the end, 1 person chose 6. Okay, and nobody chose 7. So you see, immediately we're seeing some patterns here, right? Seeing some kind of trend that is, at least among the 5, this is among the 6 of us, more people are holding some kind of a moderate attitude toward iPhone, right? Um, Relatively fewer people are holding more extreme values, right? Extremely likely or not at all, right? So nobody are holding very few people. There's one, but relatively fewer people were holding extreme values or extreme attitudes toward iPhone. Okay, so this is a distribution. Okay, how our numbers, how our this values are distributed across our sample, a sample of 6 people in this case. Okay, all right. We can look at another example. This time we can look at murder rates, right? So FBI or some other branches of the government, or even among scientists, social scientists, they're very interested in the murder rates, or any kind of other rates, um, in this country. And they typically, one way to organize those numbers is by looking at murder rates by state, right? Which murder rates are number of murders, right, or cases of murders per 100,000 population. Okay. All right. So this is the table. Fantastic. We have all the states, right, from Alabama to Wyoming, right? All the states, including Alaska and Hawaii. Is there DC here? There's no DC. I don't see DC here. Okay, so it's just the states. Okay, so 48 um, contiguous states pluses the 2. Okay, Alaska and Hawaii. Okay, so here by the name of each state, there is a number representing, right, the number of the murder rates. Okay, so in Alabama, there's the rate is 11.6. That is, remember, right? So the actual rate is per 100,000 population, right? So obviously, higher numbers means higher murder rates. So which state do you see here has the highest murder rates? Louisiana, probably 20.3. It's not the most safe state in this country. Well, which state has the lowest murder rate? Is Hawaii 3.8? It's pretty low. Montana is lower. New Hampshire is even lower. Oh, there we go. The champion is Maine, 1.6. Fantastic. Okay, anyway, right? So this table already is a kind of distribution, right? It sort of summarizes in a very crude way, right? And also very detailed way, right? How murder rates are distributed across all 50 states. Okay, but there's a problem. The problem, as we just saw, you know, going through, what is the state that has lowest murder rate, what is the state that has the highest murder rate. That these numbers there are too many of them that our brain can hardly see any pattern from it. So if I ask you, how many states are there that has murder rates that's lower than 10, or how many states are there that have murder rates that are higher than 20 or higher than 15, right? Then each time you have to go through these numbers and make tallies. So that take time, right? So while this table is pretty informative it is perhaps not the most informative way of presenting these numbers. So what scientists will do, of course, well, this is not to say that this table is not useful, right? It is useful when we try to pinpoint a specific state, but it is not very useful when we're trying to see the trend, okay? So what scientists typically do is they will come up with this kind of table, right? And they will first of all manually designate some kind of interval, right? So they break the motor rates. Instead of listing every possible single value here, they break the motor rates into several intervals, right? So from 0 to 2.9, from 3 to 5.9, etc. Okay? And then they will try to tally, okay, how many states will fall into each of these categories or intervals. So then we can see, what is the most, you know, uh, uh, um, what is the most common interval, so to speak, right? What is the most common interval of motor rates in America, and what are the relatively rare intervals for motor rates in America? Okay, so okay, I tallied all these numbers for you, because we obviously cannot do this, asking you to do this as we could in a face-to-face lecture. Okay, so anyway, tallying this is not very difficult. It just you need to be very careful. So here, we see that there are 4 states that have motor rates that's between 0 and 2.9, and you have the rest. So if I ask you, okay, so I don't know, Crystal, um, what is the most common sort of motor rates in the United States among the 50 states? Then by looking at this table, you will have no problem, or everybody should have no problem in identifying the interval, right, of motor rates that's most common in this country, and that is 3.0 to 5.9, because there are 17 states. Okay, that's the largest number compared to all the rest numbers. And I verified that these numbers are correct by summing them up, and the sum is 50. Okay, so this is also a distribution, and this tallies, the distribution, how these intervals are distributed across the 50 states. Okay. All right, so now we can sort of have a more formal definition of what we call frequency distribution. So frequency distribution essentially to list the number of occurrences, right, or the number of times that an outcome of a variable occurs. Okay, an outcome simply means a value that this variable can take, right? So in terms of our first question, the variable is the liking of iPhone. Okay, the liking of iPhone. So this variable, obviously, as we just saw, can take the value from 1 to 7. And we tally that, how many ones, how many twos, how many threes, all the way to how many sevens, right? Other than we actually observed. The second variable we look at is murder rates, right? Murder rates. Obviously, this is also a variable because this rate varies across states. And what we did is we tally, the number of occurrences of each interval, right? From 0 to 2.9, I believe that's the first interval, right? So how many times these intervals occurs across the 50 states? Okay, so that's what we mean by a listing of the number of times that each possible outcome of a variable occurs. That is, each possible value of a variable occurs. So obviously, as you saw, the possible outcome can be concrete values or exact values, right? 1 or 2 or 7, right? Or it could be intervals of values, right? And this is most useful when the values don't repeat themselves. That is, as we saw in this case, right? Rarely, you have exactly identical numbers. Um, that gives you too many numbers. In this case, 50. Well, if we're going to tally the murder rates across the world, when you have 200 plus countries and geographic, geopolitical regions, then you have 200 plus numbers. That simply is too many, right? Um, in that case, using intervals will be very useful. Okay. So frequency is very useful and is commonly used in many contexts. Um, and there are different types of frequencies. So what we just saw are frequency counts, right? We simply count how many times. One time, twice, three times, four times, etc. Right? We also call those absolute frequency. Um, but what absolute frequency mean um, can vary, right? Sometimes, uh, the same frequency, the same absolute frequency, can mean different things, and if we don't, you know, um, specify the context of this, absolute frequency, we might have, the wrong conclusion. So, for example, um, we can say that there, a frequency. We can say that there's a frequency of 5, right? But this frequency of 5, has very different meaning when we say we count that this outcome occurs 5 times out of 10 occurrences, or we observe 5 times occurrences out of 100 trials, 100 attempts. So obviously then 5, this number here, has different meaning. 5 in this context means, actually it means half. Half of the time we'll observe a particular outcome. But 5 in this context simply means this outcome is very rare, because 5 out of 100, that is 1/20th. That is 0.05. Am I correct? God, my math's a little rusty. Um, 5 out of 100. Yeah, exactly. 0.05. That means 5%. That means this event in this context is, after all, not that common. It's very rare, actually. Okay, so that's what we mean. Frequency, absolute frequency is useful, but it can be misleading depending on how many numbers, how many trials, or how many total occurrences that you have. Okay, so that's why we need a second type of frequency, and we call it relative frequency. And relative frequency is very close to what we mean by probability, right? So the definition of relative frequency is this: it is the proportion. Now it's not the absolute number, right? It's a proportion. It's a ratio um, of the observations with which the value is associated, right? And it is calculated by, right? So you have the number of observations associated with the value. So let's say the value that you're interested in is your liking of iPhone, the liking of iPhone, right? Liking of iPhone on a 7-point scale. So you're interested in, how many people scored 7. So the value that you're interested in is 7. Okay? And how many people score 7? Well, in our example, 0. Okay? So there are 0 observations associated with the value. Well, let's 0 is not interesting at all. So let's imagine that actually there are one person, right, score 7. So the number of observations associated with the value 7 is 1. But then the next thing we need to figure out in order to calculate relative frequency is what is the total amount of observations? Okay, and we need to divide this one, the number of observations associated with 7, by the total amount of observations. So total amount of observations simply is sample size. That is how many people we surveyed. Okay, because if the sample size, let's say the sample size is 5, that means we have 5 observations. That is, we have 5 numbers, providing that each person provides one number, right? So the total number of observations in most cases will be equal to sample size. Okay, so here will be, in our example, we say that there are 6 people because the number should include me, right? 5 of you plus 1, so 6. So number of observation is 5. Okay, so now we have the relative frequency. That's 1 over 5. That is 0.2. Okay, and sometimes this relative frequency is also expressed as percentages. Okay, and that's very easy to convert this fraction number to percentages. You just simply times 100, right? That gives you 20%. That means 20% of the people that we surveyed indicate extreme liking of iPhone. How about that? Okay,